Alright, today's job in the lab is to take this pile of junk and then turn it into a solar powered street address sign that'll sit on the mailbox. It'll turn on when it gets dark and it'll turn off when the sun comes out. Is it easy? Is it hard? I don't know. Let's find out. For a run through the key parts, first off we have our solar panel here. This is like I think it's a 7.5 watt 12 volt solar panel that can have a max of 18 volts charging. This is going to print it on a bracket here that will go and it will sit on the mailbox and collect up all those juicy sun rays. Next we have here is our photosensitive switch. This is what we're going to use to control the LEDs from going on and off that'll sit inside. Following on, here is the housing here. So this is actually printed in 2 pieces. Actually 3 pieces if you include the base behind here, but all this is just translucent numbers here that project through the casing that will be lit up by LEDs along the back side here. Don't mind that break, that's because the letters were printed individually. And then it will be all closed up with this this back plate here. I've included an extra diffuser piece similar to my mood lights. That will really help to smooth that out and make it a uniform glow. Alright, so here we have a charge controller. This will make sure that the solar panel does not A, overcharge our battery, provide too much voltage for the poor cell here, and B, to make sure that it doesn't backfeed into the solar panel when we lose it, because the circuit can flow in the other direction, which would basically make this whole circuit useless. So the whole point is that we want to capture the pixies that this takes sunlight and turns them into, and then put it in the battery and keep it there, and then use this battery to feed the LEDs, which will be stuck in here. Next we have just a simple battery. So this is just something you can easily find on Amazon. It's a 12 volt sealed lead acid battery. Pretty standard. They use these for just about everything. Here's just the mount that'll be used to put it on. It'll probably be printed black for the official version since it's just PLA, but I wanted a quick mock-up. And then last but not least, we have our roll of 12 volt LEDs that we'll be using to light up the inside of this panel here. So to light the inside of the housing here, all I did is have a strip of LEDs that go along the center of this piece here, or close to the center. Eyeball laser, after all, might need some calibration. And there's a pocket on the back side with some, well, there'll be brass M3 inserts in all 4 corners. And all you have to do is butt up the back of the container here to the end and let the wires come out. So the wires will be routed in the channels and then it will exit as it sits on here. So that's what the small cutout, make sure that you guys can see that. That's what that small cutout is, to allow the wires to leave around the post and then be routed back up to the battery while not letting in water that will be dripping down from the top. So it still is protected from a water entry. That's also why there's actually a hole in the bottom that I'm using to plug it into, is because any water that does get in here I want to drain out the bottom, because otherwise we'll have pooling and that will cause all sorts of havoc with our electronic systems. Yay! So here is the lit letters, and you know, so far it's working pretty well. By turning down the exposure, you can clearly see the lights are strongest down the center, and then it fades to the outside just because they're in a strip. I could solve this by also adding in an extra layer of LEDs on either side, just kind of spread the light around more and add more light total, but that would double the wattage, and that would mean that we might run into issues with battery life, especially during the colder and darker months here in the north. Alright, now we have our switch hooked up into the system here. So what we have is the back of the switch here has the load being on the red, so the load being the powered wire that when the switch is activated allows the power to go through. We have the neutral as the white, so that's ground, and then we have the line as black. So here on our switch we have our black hooked up solo to the positive of this connector here. We have the white hooked up to the negative, and then we have the red hooked up to the positive or power line of the LED strip here. To complete the circuit for the LEDs, we have the black going back to ground as well. So that is a shared terminal, and that's how we'll have to hook it up. So let's give it a shot and see if we can make the switch actually. Okay, so right now the switch is supposed to be off since it is sensing light. So if we turn off the lights, and it turns on the lights. So it looks like we have a functional switch and a functional premise. So it takes a couple seconds to turn on the switch, which is actually desired behavior. It's kind of like going under an underpass, and then your car's lights automatically turn on, and then you get out of the underpass and turn off. We don't want that kind of behavior. We want it to settle down, and maybe it's cloudy outside and it's cloudy for a decent amount of time. We want those lights to turn on. So ideally it would be a day-night cycle, and we could have it set to like average over an hour. But with a simple, probably mechanical switch on the inside that doesn't really have too many brains, this is a pretty good solution.
The circuit works as follows. The solar panel receives power from the sun and feeds that into the charge controller. The charge controller then distributes that power to both the photosensitive switch and the battery, which uses the energy to charge its internal cell. Since the switch is in the sunlight, the switch does not complete the circuit to the LEDs. In the nighttime, there is no voltage produced by the solar panel. If it were not for the diode, which is an electronic one-way check valve, the solar panel would actually consume power at night. The charge controller will still allow power to flow to the photosensitive switch, which will now close the circuit and allow the LEDs to turn on.
So, to put in the brass insert, all you need to do is take your torch, however you choose, heat up the insert till it gets hot enough to melt the plastic around it, but not too terribly hot, so don't heat it up glowing red. And then try to insert it as straight as possible into the plastic. Try not to weeble wobble like I do, but then all you need to do is let it cool, and so the brass insert with those knurled edges all the way around will properly focus. So the little knurled edges on here will properly grab onto the plastic and make a nice spot for the screws to thread into. Alright, so it looks like the solar panel, while it's in the house, underneath a 15-watt LED light bulb, we'll take it outside and see if it can generate at least 12 volts on this particularly awful day and awful time. It's fairly late in the afternoon, and so this should be about the worst case of where I would expect it to actually charge during the day. Alright, so it looks like that even in this particularly awful environment, so the sun is already setting out there, it's very overcast, it looks like we're still able to get above, around or above 12 volts, which is basically what I'm looking for. So during the day, this thing will definitely be generating enough voltage to start charging the battery, and it's the actual power it outputs is different than the voltage that it has, but at least it should be able to generate at least a trickle charge throughout the day, and the battery is oversized for at least a couple of these days. So I'll head back inside and see what happens. Okay, and then here we are on a nice sunny day without a load, and we're at 25 volts. So on a good day, we definitely should be getting enough the rated power that it has, which is what we'll need to make sure that it can charge the battery during the day, and the battery discharges overnight. So pretty good value there.
The first thing I did for installation was to make sure that my guess as to how the solar panel would be installed was correct. This will be installed later using self-tapping screws into the back of the mailbox. Then I set about making sure that the enclosures would work correctly and install on the post. Turns out my little brother wasn't 100% accurate on the real measurements of the 4x4, and the post came in a touch large. This is why the parts are able to be held on without any screws. Next, I fastened down the enclosures with some screws. Since I forgot to bring my iron, I opted to leave the wires coming straight out of the bottom and to wrap them around the back of the post, instead of hiding them inside of the enclosure. With the number of enclosures installed, it was time to figure out the best spot for the battery. Due to the wire lengths as well as being hidden from the elements and anything being splashed from the road, I positioned the battery carrier as close to the mailbox as possible. Next comes the installation of the light switch. I originally tried to bias it toward the rising sun, as I figured that the lights would be the most useful at nighttime when coming home from work or a night out. I also started to hook up the wiring. Next, it was time to install the charge controller. This was installed using double-sided Velcro, since that's what we had, and was put on the back of the battery case, also hidden from the elements. My dad then came out to see how the project was going. He installed the solar panel and helped to hook up the remaining wires. After review of the wiring and assembly, we decided it would be best to put the light switch directly behind the post, since it didn't seem to be terribly direction dependent, and that significantly cleaned up the appearance and vulnerability of the wiring. With everything all buttoned up, all we could do was wait for the sun to go down. See, it stands out surprisingly well at night in my parents' neighborhood, and it's made finding the property much easier. It may have also inadvertently made my parents' mailbox a pretty attractive target for juvenile vandalism, but that's just the way things are sometimes. There'll be a link below to Thingiverse with a blank face and insert for anyone who feels like doing the same. If you like this, hit like, subscribe to my channel if you'd like to see more content like this in the future, leave a comment down below if you have questions or comments, and I hope that this gave you some idea of a project that you could do at home just like this or similar. Thanks for watching. Hasta la bye bye.